Hi, this is Sung. I'm your online maths mentor, and I'm just getting tongue-tied here, but basically what we have done up until now is gone through the chapter on, or the topic of, permutations and combinations. We've pretty much thoroughly covered permutations now, and what I do want to do is look at combinations and how combinations are slightly different from permutations. Now, you will have recalled that permutations is all about the number of arrangements that you can have. Yeah, the number of arrangements that you have are called a permutation, okay? The permutations. And the thing with permutations is that the order of the arrangements will matter. On the other hand, you've got combinations, right? And combinations, another word for combinations, is all about selections. Selecting a subgroup from a bigger group, okay? So, where you're dealing with combinations, you're not necessarily worried about the order. So the order does not matter as much. It's almost like you've got a bag, right? And in this random bag, you've got a whole bunch of little goodies, and what you've got is a smaller bag, and you are making a selection out of the bigger bag into the smaller bag. Now, when you take the selection out of the smaller bag, a bigger bag, and put it into the smaller bag, and you put it into the bag, doesn't matter the order in which those objects you put into the smaller bag are in. Well, not really. It doesn't matter, because after a while in the bag, they're just going to turn into, they're just going to move around randomly and not be in any order. So the order really doesn't matter. And that's really what a combination is. You're looking at what's inside the bag, not necessarily the order that they're going to be in the bag. They're not the order that they are going to be in the bag, right? So you're looking at a selection as opposed to an arrangement, right? So you're looking at where order does not matter as opposed to where in an arrangement order did matter, all right? Cool. So that's really what a combination is, right? And just like we worked out the formula, or the general formula for a permutation was NPR equals to N factorial over N minus R factorial. You've actually got the same thing for combinations, right? So where you've got N objects in your big bag, so in your bigger group, in your bigger complete group, you've got N objects, and you're selecting R of them, okay, then the formula will be N factorial over R factorial times N minus R factorial, okay? So that's your formula, all right? And if you want to work it out on your calculator, there is a button on your calculator that you can work it out on, all right? And on your trusty Casio, it'll be the next button over to where your NPR button is. So it'll be NCR, which is going to be where the division button is, but you've got to press the shift division button to get to it, okay? So that's where it is, all right? Let me show you how we get this particular formula. Let me start off by doing this question on the board. It says, how many ways can you select 4 people from a group of 10, okay? Now, if we're looking for the number of arrangements or the number of permutations, what we will have is 4 positions, remember? 1, 2, 3, 4. In this position here, you can put, or you can make 10 choices. You've got a choice of 10 to put in position 1. In position 2, you've got 9 choices to put in position 2. In position 3, you've got 8 choices, and in position 4, you've got 7 choices. Do you see that? And so your answer will be 10 times 9 times 8 times 7, which, all right, ends up being 10, whoops, I don't know why I wrote 18, which ends up being 10 factorial over, because you've got 4 positions here, it'll be 10 minus 4, which is 6 factorial, right? Does that make sense? So 10 times 9 times 8 times 7 will be 10 factorial over 6 factorial. Do you see that? So it's basically 10 factorial over n minus r, which is 6 factorial. All right, cool. So it's 10 factorial over 6 factorial. That will be, all right, the number of permutations that you will have. So that will be 10p6. Do you get that? All right, cool. Now, what I want you to notice is that you've got whatever values that you have for each of these positions can be rearranged. These 4 positions can be rearranged in 4 factorial ways. Do you see that? So, P1, P2, P3, P4 can be arranged 4 factorial ways. Do you see that? Okay, and the reason why is you've got 1, 2, 3, 4. You've got 4 choices that you can put in here. P1, P2, P3, or P4. Those 4 choices you can put here. You've got 3 choices. You've got 3 positions left to put in position 2. 2 positions left to put in to this one, and then you've got 1 position. So you've got 4 factorial ways that P1, P2, P3, and P4 can be arranged, right? Now, can you see that those 4 factorial ways, that all those 4 factorial arrangements are actually not one arrangement, but they're actually one combination, yeah? So if you were to put P1, P2, P3, and P4 into a bag, right, that's actually one combination. The fact that they get jumbled up, right, doesn't mean that you've got more than one combination. They're still the same combination. They're still the same elements in the same bag. They're one combination for 4 factorial arrangements. Does that make sense? So what you need to do is you need to take this, all right, 10p6, and you've got to put it on 4 factorial. Does that make sense? And that will give you 10, choose 6. That will give you the number of combinations where you choose 6 from 10. Okay? Good. Now, here's what I want you to notice. 10 choose 6 will also be equal to, another way you can write it is 10 factorial over 6 factorial over 4 factorial. Do you see that? 10 factorial over 6 factorial is your 10 choose 6. 10 choose the number of permutations where you choose 6 from 10. And then you've got to divide by 4 factorial. And so the number of combinations where you choose 6 from 10 is going to be 10 factorial over 6 factorial over 4 factorial, which is exactly what we have over here. Okay? And that's how you get this particular formula. The other thing that I wanted to bring to your attention is 10 choose 6 is actually, right, 10 factorial over 6 factorial over 4 factorial. Now 10 choose 4 is also the same thing. 10 factorial over 4 factorial over 6 factorial, which is, can you see that they're actually the same thing? Right? So in other words, if these two numbers add up to 10, right, they're actually going to be equal to each other. So in other words, if this number and this number add up to these numbers there, they're actually going to be equal to each other. Now, let me ask you a question. Can you think why that might be the case? Can you think why this and this are equal to each other? Let me give you a hint. If you choose 4 objects out of a pool of 10 objects, right, what are you left with on the other side? You're left with another combination where you've got 6 left over. Does that make sense? And so the number of combinations where you choose where you choose 4 will be the same as the number of combinations of whatever you have left over. Does that make sense? Yeah. So that is why 10 choose 6, or choosing 6 from a pool of 10 will give you the same number of combinations as choosing 4 from a pool of 10 as well. Okay, good. Yeah. So let's come over to this side. More generally speaking, how many ways can you select R people from a group of N people? Okay, so in other words, instead of using the numbers 4 and 10, we're going to use the letters R and N. All right, so instead of using the numbers 4 and 10, R and N. Okay, so basically what you've got is that N choose R, the number of combinations N choose R is going to be the number of permutations N choose R over N factorial. Okay, so it's the number of permutations divided by the arrangements of whatever selection that we made, right? So that's going to be, all right, N factorial over N minus R factorial divided by N factorial, which gives you, sorry, not N factorial, R factorial, and that's going to be R factorial as well, sorry. And that's going to be give you N factorial over N minus R factorial R factorial, okay? And that basically is the formula that we have over here, okay? So what I want you to really get from this is that however many permutations that you have, or however many arrangements that you have of choosing R objects from N, you're going to have less combinations of choosing the same amount, because the number of combinations doesn't take into consideration the order, whereas all the permutations will take into account all the numbers of orders that you will have. Okay, so that would be the key difference. In the next episode, right, I am going to go through a number of more in-depth examples of how to use this principle. So if you didn't get it the first time, it's okay. You will get it as we do more examples of this stuff. But what I will recommend that you do is go back, review this episode, and try to familiarize yourself with it. Thank you very much for watching. Bye.